Jai Hind everyone. My name is Aman Gupta and I am working as an assistant professor in MC department in Ajay Kumar Garg Engineering College. My subject is software engineering whose subject code is BMC30T. Today's topic is software characteristics and its components. So first of all, the first thing that we need to understand when we talk about software, that what is a program. So everything that is going around software is a program, and a program is a list of instructions, a set of sequential logical instructions, the combination of some logical instructions to complete a task is called a program. So software is a set of items or objects that form a configuration that includes programs, documents and data. All of these things collectively called the software. The software comprises of programs, documents and data. Or we can say that software consists of instruction in the form of computer programs or a set of instructions that when executed provide desired function or result performance that may be obtained as a result in the form of the complete task. Second one is the data structures that enable the programs to adequately manipulate, calculate the information. And third one is the documents that describe the operation and use of the programs. So document is required because everything that we have to do in our software has to be written down somewhere. So for this task we need some documents. But these parts, only the concrete parts of software that may be seen, that there also exist an invisible part. So what is that invisible part? It is the dynamic behavior of the programs on real computers and on the auxiliary equipment. So that is the important part of any software, that is the dynamic behavior. This is the attributes of a software, that software product is a model of the real world and the real world is constantly changing. So that's why our software is also is the nature of software is to be changed accordingly, according to the needs, that is changed frequently according to the real world problem occurred. So software is the digital form of knowledge, by which a particular set of instructions has been processed and give the desired function or desired output that has been required by the client or the end user. So we can define a software as computer programs and associated documentation that is in the form of requirements, design models and also in the form of user manuals. So software products may be developed for a particular customer or may be developed for a general market. So we can develop, or a software engineer can develop some software products according to the need of a particular user or a particular client, or maybe he can produce or any type of software for a general purpose, for a generalized purpose that can be used by many customers. So software products may be generic and bespoke. So what is generic? The software can be developed to be sold to a range of different customers. Suppose, for example, software Excel, Word. So these are the generic software that has been required by almost all the users. So these are generic softwares. And if we talk about bespoke, means customized software that has been changed according to the need of the user or the client. So these softwares has been developed for single customer according to their specification according to their needs, that what they need, what they want, that the particular software have to do this thing, that thing. And new software can be created by developing new programs, configuring generic software systems, or using the existing software. So every time when a new software has been developed, maybe it has been developed by very scratch, or maybe he can use generic software and then he can customize it, and maybe he can reuse the existing software as a template, and then he can modify or change the software. So these are the components of software. First one is program, documentation, and operating procedure. The combination of these three made the software. So these are the software equals to program plus documentation and plus operating procedures. Now these are some characteristics of software, that software is developed or engineered and is not manufactured. It means that software is developed according to the need of a customer or a client. So it is developed or engineered according to the requirements, but it is not a machine, because machine can be manufactured according to the need, but a software is implemented according to the needs of user. Then software is malleable. Malleable means it can be changed easily. So because if a machine has been manufactured, it is very difficult to change the parts, to every time to purchase a new part, it is very difficult. But in a software, it is changeable, it is easy to incorporate new components, new parts, new functionality to a software is much easier than the hardware, than we manufactured any hardware. So software construction is human intensive. Human intensive means that it required the logic functionalities provided by the human mind. Only then it's possible that a software has been developed easily and effectively. Next is software intangible and hard to measure. It is difficult to measure the software because every time there may be some changes that occurred until it has been finalized. And software problems are usually complex. It has to be, if we have some problem that are very lengthy or complex, then it is easy to develop a software to accomplish all the tasks in a software easily. Software directly depends upon the hardware. Software is dependent on hardware in terms of configuration, that it is supported by following operating system, what type of Windows, what type of RAM, ROM, hard disk. So that type of need required in the software. Software solution requires unusual rigor, that it can be changed frequently. Most software are custom built rather than assembled from existing components. So softwares can, as we know that it is easy to customize software, so these softwares are custom built, means according to the need of user, rather it can be assembled from the existing components. Next is software does not wear out, but it will deteriorate. Failure, this is the failure curve of hardware, that when first of all a hardware has been built, then its failure chances are very high. This is burn-in phase. After the time being, it is in a for maybe 3 to 4 years, it is in this time frame, it is a useful life phase, that it is working fine. Again, after 4 years, it is the wear out phase, and this is very high, means the failure intensity is again increasing. This is the failure curve of hardware. And if we talk about the failure curve of software, This is the failure curve of software, because software are flexible and discontinuous. As we can see, this is incontinuous operational in nature, because we have implemented changes very frequently according to our needs. So this is the failure rate. So it has been fluctuating very frequently. Now there are software application domains. That software is a general term for various kinds of programs that are used to computers and related devices. So we have different type of softwares available. First of all, a system software. What are system software? These are the collection of programs to provide services to other programs. So infrastructure software comes under this category, like compilers, editors, drivers, operating system. All of these are comes under the system software. Next one is our real-time software. So these software are used to monitor, control and analyze real-world events. So real-time computing or reactive computing describes hardware and software systems subject to a real-time constant. For example, from event to a system response. So real-time programs must guarantee a responsive within specified time constants that we called as the deadline. For example, software required for the weather forecasting. So this is the example of real-time software. Now next category is embedded software. So this type of software is placed in read-only memory of the product and control the various function of the product. So these software refers to the computer program that directly interact with the hardware. So these type of software have implemented with the specification of according to the specification of the hardware. So these built to perform a specific function or to make the hardware perform in a specific way, and several pieces of embedded software may be built into a single piece of hardware. So embedded software is an integral part of hardware into which it is built. So products could be an automobile, security systems, signaling systems. So these type of softwares comes under the embedded software. So it handles hardware components and is also, we can also term it as the intelligent softwares. So for example, ATMs, cell phones, printers, thermostats, calculators and also the video game consoles. These are all comes under the embedded software. Next category is of business software. So business software or business application is any software or set of computer program used by business users to perform various business functions. So these business applications are used to increase productivity, to measure productivity and to perform other business functions accurately. So main reason to develop these type of business application to increase the productivity of any organization. So software designed for business application is called business software. So these software has been developed especially for the business purposes for any organization. For example, CMS. For example, CRM, Customer Relationship Management Database, Enterprise Resource Planning, ERP. These type of softwares are working fine in any type of organization. Next one is the personal computer software. So software used in personal computers is covered in this category. For example, word processor, computer graphics, multimedia animation. So this can be these softwares can be used for our personal use. We can develop it for our own use. Next is our artificial intelligence software. It makes use of non-numerical algorithms to solve complex problems, so that are not amenable to computation or straightforward analysis. So in these AI software, for particular algorithms has been used to solve some complex problems. For example, expert system, neural networks, these type of softwares are the examples of AI software. Next category is web-based software. So these type of software used over internet with a web browser. So we don't have to install any CDs, download any software directly, or worry about any type of upgrades. So if you use an online bank or web-based email program like any type of mail ID, Gmail, Hotmail, Yahoo Mail, then you are already used web-based software. These type of mails or applications comes under the web-based software. For example, CGI, HTML, Java, all these made up of using that type of languages. Next is engineering and scientific software. So huge computing is normally required to process the data. For example, CAD/CAM, circuit analyzer, these are under the scientific software. Now next topic in this is software crisis. What is software crisis? So this is a term used in computer science to describe the difficulty of writing useful and efficient computer programs in the required time. So this software crisis is the problem that if we see that demand is higher than the production, then it results into the software crisis. So software crisis was due to using the same workforce, we have same methods, same tools, but we have minimum less time frame to accomplish all the tasks. So these tools, despite rapidly increasing software demand, the complexity of software and software challenges, but because the software demand increases, but we don't have much workforce and different methods to complete the task, so it can be result in a software crisis. So with the increase in software complexity, many software problems arose because existing methods were insufficient. We don't have sufficient methods to complete our task. So we can see through this that if software crisis occurs when we have same workforce, we have same methods, and we have same tools. Demand is increasing, complexity is increasing, and challenges are increasing. So that's why it results in software crisis. Now symptom of software crisis are 20% of client server apps are abandoned or restarted from the scratch. So this is a example of software crisis. 30% of apps are significantly altered to avoid disaster, and 50% of apps are delivered significantly late. So this may be the reason of some software crisis. So, and what is the reason behind why software fails? So why software fails? First of all, it can crash frequently, expensive, difficult to alter, debug, enhance. These may be the reason for software failure. Often delivered late, use resources non-optimally. Software professionals lack engineering training. Programmers have skills for programming, but without the engineering mindset about a process discipline. So these will be the reasons of the software crisis. Now there is a difference between a program and products. So programs, we can differentiate it with some points that programs usually small in size and software products are large in size. Program is a small part of a software. It is a this is a software product and it is a program. These are the programs. So actually we can say that it is a subset of the software. Author himself is sole user. This is program and large number of users. Software products can be used by large number of users. A program is developed by a single developer and software product is developed by a team of developers. Lacks proper user interface. Maybe it can work through API, We can use it. This is a small program which have implemented some functionality, and we can use this program in our software, any software procedure or product. So this can lack a software user interface. And if we talk about software product, it has a well-defined, well-designed interface through which a client can interact with the any application. It lacks proper documentation, and it has a proper well-documented user manual, ad hoc development, and it has systematic development. So these are some differences between a program and a software. Now there are some computer myths that we have. We can see that if we talk about from the customer perspective, customer can think that a general statement of objective is sufficient to get started with the development of software. So a user can think, if I have to make some software, maybe I can think that some information I should give to the vendor, and he can start working on that software. So missing requirements can easily be incorporated detail as they get concretized. So a user or a client, maybe he's thinking that with less information or with small information, software can be prepared and changed frequently. Software is easy to change. It is very easy that every time I will give some suggestions, I will give change my requirement. It is very easy to incorporate in any software, but actually it is not. Software with more features is better software. If we have a multiple features in our software, means I have 100 of features in a software, then it is the best software. So it is also a myth according to the customer perspective. Now with the if you see the developer perspective, once the software is demonstrated, the job is done. No, until the software is coded and is available for testing, there is no way for assessing its quality. It can be changed, but actually if we see that testing is the part at every phase. If we see through SDLC, testing should be done at every phase of our software development. The only deliverable for a software development project is the tested code. It is also not true, but it can be a myth according to the developer perspective. Now, according to the management perspective, as long as there are good standards and clear procedures in my company, I should not be too concerned. This is also not true, but through management perspective, it can be true. So, as long as my software engineers have access to the fastest and the most sophisticated computer environment, everything will be good. And as I am the one who is provided the best resources, best software tools. So it is not my duty, it's not my concern. Now it's not my concern to involve in all the activities that have been done. So this is also a myth of the myth from the perspective of management. Now we have P3s, 3P3, that is project, product and process. So what is project? Sequence of tasks planned from beginning to end and bounded by time, resources and required results with defined outcome and the result and the product, that is called deliverables. So this is combinedly, collectively called a project. What is product? What is delivered to the customer is called the product. It may include source code, specification doc, anything else that I am going to deliver to the end user. That is the product. And the process, it is the way in which we produce our software. It is the way I have occupied. It is a collection of activities that leads to a part of a product, that which SDLC model I have used, the process I have adapted to develop my software. So that this is called the process. So, role of management in software development, that is management dependency order is people, that is 1, product is 2, process is 3, and finally what is needed? Deliverable, that is project, all over project. So, the people is software development needs good manager. Good managers are needed when a software has been developed. They understand the psychology of people and provide good leadership. So, they increase the probability of success. So, this is the role of the people that have been used or that have some role in developing a software. Areas in which they have a role are proper selection, training, compensation, career development, work culture. In all these domains, managers or the people involved have their roles. Next is the product, a solution to customers' problem. That is the solution. Product is the final product, hence the objective and scope of work should be defined clearly. Alternate solutions to be discussed. And it also helps the managers to select the best approach within the constraints. Without well-defined requirement, it may be possible to define the reasonable estimates of cost, development time, and schedule for the project. It can be possible with the help of the product. Next is the process. This is the way in which we produce the software. It is the framework from which the comprehensive plan for software development can be established. And many life cycle models have been available, and process improvement models are available to develop a software. Next is the project. Proper planning is required to monitor the status of development and to control the complexity. So, most projects are coming late with cost overruns of more than 100%. So, concrete requirements to be defined and freezed, then only we should start, or the developer should start working on some software. Changes should not be incorporated as they are always risky. So, that's why the developer first made a SRS or a documentation, proper documentation, and freeze a requirement before starting any type of software. So, that's all for today. Thank you so much.